Hello, nerds. You can greet me back.
Hello, hi, nerd.
Okay, yes, see? Hi, nerd. That's the only appropriate response. Anyway, we back at it. Get out of here. We back at it. We're going to go ahead and finish up section 1.1, I think? Yeah, we're still on 1.1. And here, this is my YouTuber voice. I told you, that door is not a portal. I can't change just because I walk through it, and I'm not going to change just because I turn the camera on. If I need to roast you, Jack, I will. Okay, so, anyway, that's Jack Walcott for all of YouTube to know. Okay? Okay, anyway. And Mr. Walcott. All right, anyway. It says solve the equation both algebraically and graphically. Now, yesterday we did a question like that, right? And we said that in order to solve algebraically, the very first thing we had to do was set it equal to 0. Okay, well, if we were going to solve this thing algebraically, that would be the first thing there as well. Set it equal to 0. That means I like my leading coefficient to be positive, so I would move the 10 and the negative 4x to the left. And we would accomplish that by subtracting 10 and adding 4x. But here's the thing. We've all taken Algebra 1, so I'm not going to insult your intelligence and solve this thing using the quadratic formula because, well, that's the unfortunate part about it. It doesn't factor. We would have to solve by using the quadratic formula. We're just going to pretend that we did that for time purposes because hopefully you all know the quadratic formula, know how to use it. I'll tell you the answers aren't pretty. They're irrational, like a lot of things that the quadratic formula is going to get you. But we want to solve it graphically because it's important for me and for you that you know how to use your graphing technology appropriately. So we get handy dandy graphing calculator on here, turn it on. And just on screen here is this y equals. So you go to the y equals menu, and I have to clear some stuff. So let me clear that out. That was from the last time I used my calculator. Here's what we're going to do. We're not going to graph this. I could graph this, and I could ask the calculator to show me where it crosses the x-axis, which is what would give me 0. Even better than that, I'm going to say this is two different equations. I'm going to say the first one is y equals x squared. This is x right here next to alpha. That's the variable button. And you do have a square button right here. So y equals x squared. And the second equation, you're just going to scroll down with the down arrow. I'm going to type as 10 minus 4x. Real quick, this button is not minus. This button is negative. This is the minus button. Okay. I know that you're being a smart aleck back there, but I had people earlier use the negative button instead of the minus sign by accident, and they couldn't figure out why their graph was wrong. So I do have to teach you that. Okay. Now, out of years and years and years of graphing experience with these things, I have gotten into the habit of, and I'm going to ask that you do the same, that you don't just hit the graph button. Here's why. There's a good chance you were using this thing at some point in time in your recent history, and the last time you graphed something, you had to goof with the window, and you gave it a weird space to graph in. So what I've gotten in the habit of doing, before I press graph, not even pressing graph, I hit this zoom button, and then I hit the number 6, which takes me to the standard graphing size window, which means 6 or 10 in all 4 directions. There's x squared. There's 10 minus 4x. Now this is a quadratic. It would have 2 solutions. Solutions are places in space where graphs intersect. And that is an Algebra 1 and Algebra 2 standard that the student understands that when you solve an equation like this, you're literally finding the places in space where those graphs intersect. I know there's 2 answers. I can only see one of them. Why? Because my window is wrong. You see, there's another answer somewhere out here-ish on the y-axis. I need a lot more y values in order to see that. There's a good chance, though, that it's still going to fit within x equals negative 10. We need to adjust our window. You know what y values don't matter? The negative ones. They're not important. So when I go to my window, which is that button right there, I'm not going to mess with the y minimum. It says y minimum is negative 10. We're fine with that. That's not a problem. And my x minimum, x maximum also were not an issue. What I'm going to do is I'm going to go to my y maximum, and we're going to type in a new number. Anybody want to take a educated guess on how high we might need to go? 30. Let's try 30 and see what happens. 1,000 is probably way too much. Let's go to 30. Now, check this out. The distance between negative 10 and 30 is 40. If you leave your y scale at 1, you're going to have 40 tick marks on your y-axis. And the more crap you have on the screen, the slower the calculator will be at graphing it. So I'm in the habit of just figuring out the distance and then going, what would I have to divide by to get 10 marks? So that's a space of 40. I'll make my scale go by 4s. That's going to give me 10 tick marks. Whatever. And we're going to hit graph. And we're going to see if we were right or not. Really close. But 30 wasn't quite large enough. No big deal. Go back to window, make it larger. Go to 40 or 50. Let's go to 40. Now that's a space of 50 between 40 and negative 10, so I'll make those by 5s. So now I'll have 10 tick marks because 10 times 5 is 50. And we'll hit graph one more time, and hopefully it's on there. It is. Okay. We can see our two intersections. There's one here, and there's one down here, and our graphing calculator can find those for us. Here are the directions, the button clicks that you need to use. So you might want to write them down. It's going to be in the video, but still. First things first, we're asking our calculator to calculate something, intersection points. So second, and then right here, above the trace button, it says calc. So it's second, then trace. This calculator can calculate many things for us from our graphs. In this course, AP Pre-Calc, we will use all of the first 5. The last 2, those are calculus. So what does a value do? It lets you put in an x value and it'll just tell you what the y value is if you had plugged it in yourself and calculated it. So I could say, hey, what is y if x is 100? It'll tell me. Number 2, zeros. Zeros are where the graph crosses the x-axis. Mr. M, why didn't you just do this then and ask where it crosses the x-axis? Because I find that figuring out where graphs cross the x-axis is slow. It's a lot of button clicks. I just don't like to mess with it. When you have to, I'm going to tell you a way around it. Number 3, how you find a minimum is going to find the bottom of a bump. Like, so anytime you have a spaghetti-shaped graph, it'll give you a minimum value, the bottom of a valley. A maximum will give you the top of a bump. So if you have a spaghetti graph, it'll tell you where the bump happens, the x, and what the value is, the y. But my absolute favorite thing in this menu is option number 5, intersect. It's literally where do two graphs intersect. So you don't have to scroll down. You could just hit the number 5. You can graph up to 10 things at once. And the calculator doesn't know how many things you have graphed. So it's always going to ask you, was this the first thing you wanted me to look at? Is this one of the 2 that you're looking for intersections of? You tell it yes by hitting the enter key on the bottom right. It will then immediately jump to whatever you had listed as your next equation. It'll say, is this the other one? And you tell it yes again by hitting enter. And now it says, take a guess. That means get close to the intersection. So you use either left or right to get to the answers. I always go from left to right. So I'm going to start on my left. I'm just holding down the left arrow until it gets me there. That's pretty close. And just hit enter one more time. And it will give you the x comma y of the intersection. Now, we don't care about the y value. Ooh, I just hit the microphone with my hands. I forgot I was wearing a mic. We don't care about the y values because there was no y value up here. All we care about is the x. In AP Pre-Calc and AP Calculus, you're going to round to 3 decimals. So negative 5.742. And in order to find the other answer, you go through the process again. You're going to be amazed how fast second trace intersect, enter, becomes muscle memory. Second trace 5, yes, yes, and it's already waiting for me to scroll. So second trace 5, because I only have 2 graphs on my screen, I hit enter 2 times in a row. And then you just scroll until you get to the other, at least close to the other answer. Oops, went a little past it. And then hit enter again. And it says the other answer is at positive 1.742. It gave you the same decimal, someone just realized. Wait, was the other one 742 also, and I just wrote it wrong? Oh, okay, this is 742. Sometimes they'll give you the same decimal. There it is. Just because it's good note-taking, or at least you seeing it, I want to show you something here. You don't need to do this anymore. Y equals. I'm going to add a third thing. Negative x plus 20. You don't have to do any of this, okay? I'm going to hit graph. There, I have a third line on here. Let's say I want to know where the black one intersects the blue one. Second trace 5. It says, is this blue one of the ones you care about? You hit enter for yes. It instantly defaulted to Y2. But if I don't want to go to Y2, I want to go to Y3. I know it's a little counterintuitive because you're looking at the screen right now and it looks like the black one is quote unquote above the red one. But you realize in the list, the black one was below. So I hit the down arrow and it jumped to Y3. If there was a Y4, I would hit I would hit the down arrow again, it would jump to Y4. Now I could tell it yes. Okay? And then go through the whole scroll left and right. Also, I've got these 3 things on here. I don't want to have to remember to press I don't want to remember. I just want the red one not there. Okay, fine. Go back to Y equals. Let's say it's still important, but you don't want to see its graph. Scroll down to it. Hit left. Where now it's flashing on the equal sign. Hit enter. And it will unhighlight that line. And now when I hit graph, it'll only graph the blue one and the black one. Isn't that neat? Cool stuff, huh? Okay. Also, something I want to show you. I'm going to get rid of the one I made up. And instead what I'm going to do is I'm going to graph x squared plus 4x minus 10. You don't need to be doing this. You need to be watching this. X squared plus 4x minus 10. I do need to turn on my red graph. There we go. Now it's going to have to graph all 3 because I told it to change too much. There's x squared. There's 10 minus 4x. There is this purple quadratic. I would like for you to look at the x values where it crosses the x-axis. This calculator can't draw a vertical line, but if it could, guess what that vertical line would go through? So they have the same x value. This thing's x-intercept is this system's, what's the word I'm looking for? Intersection point. And over here, its x-intercept, once again, is the system's intersection point. So you could do that and solve it. Y equals, turn off, turn off. I could graph this thing and this thing only, and I could ask it to give me the zeros with second trace zeros. But I hate it. It's slow. So what do I do to get around it? I graph another equation. I graph the x-axis. Y equals 0. And then I hit graph. And then I can do second trace intersect, and I can just tell it, look for the intersection of the black thing and that purple line that it just drew, and that purple line happens to be the x-axis. It's just faster. And when you're taking a timed exam, like the AP exam, time is a big deal. Okay? That was lots of calculator stuff. So let's talk about some more academic vocabulary. It's important to me that you understand that all 3 of these statements say exactly the same thing. If I say a real number, is a solution of this equation, then I'm saying that that solution is a root of the equation. So solution and root mean the same thing. I'm saying that that number a is a 0 of y equals f of x, meaning if you graphed the equation, that's where it would cross the x-axis, a 0. Oh, and by the way, crossing the x-axis is known as an x-intercept of a graph. So to say something is a root or a solution or a 0 or an x-intercept all mean the same thing. You guys comfortable with that idea? That's okay? Yeah? Okay. Let's do some good old Algebra 1. It's just here so we can show that we can model with mathematics. The engineers at an auto manufacturer pay students 8 cents per mile plus $25 per day to road test their new vehicles. The first part of the question wants to know how much a manufacturer paid Sally if she drove 440 miles. Sounds to me like we need an equation. Now here's what's up. I'm looking for volunteers and people that I'm trying to learn all my names. So hands up for people that think they can help me come up with an equation. That way I can call on them, say what's your name and all that good stuff because I'm trying to memorize names. Can I have somebody that thinks they can give me an equation? What's your name? Mark. That's what I thought. What's Mark's friend? That's what I called him yesterday. Noah? Okay. Noah, Mark. Mark, what equation do you think that we can write in order to figure this out? I like y equals mx plus b. That's good. Well, hold on. Let's not use 440 yet. Let's just write the equation. We'll use 440 in a second. Okay. So what would the equation be? What's our slope? You said mx plus b. Good. 0.08 is our slope. And we're going to say x for now. And then what's my plus b? Plus 25. There we go. Great. Now, Mark, I believe you were going to try to do part A, but I'm going to let somebody else do it because I'm trying to learn all these names. Can I get a new hand? Someone could tell me how to, Adi, how can I actually solve question A? You put 440 in for y. So let's see. It says Sally's driving 440 miles. We get paid 0.08 miles, 0.08 cents per mile. So y is not the miles. Y is the money. So where am I going to put that 440? That's okay. There we go. So yeah, we'll do like this. Money, money, money. We'll use the 440 as an x value. So Sally gets paid 8 cents per mile for all 440 miles plus $25. And if my memory serves me correctly, from second period, that's 62 cents, $62.50? 62.50? 62.20? See, this is what I get for trying to use my memory. I should have just used my calculator. Tell you what I'm going to do. Let me grab this calculator. Here's my blank screen. Time to show you some more stuff this calculator can do. Shucks, you know what? The calculator's memory is better than mine. So you know what I'm going to do? I'm going to press the up arrow until I see the last time I did this mathematics. Oh, there it is. There's 0.08 times 440 plus 25. Yes, sir?
How far does the memory go?
How far does the memory go? Yes is the answer to that question. It will go until the calculator says you're out of memory. And it's a lot. How do we clear the memory? That's another question. Remember in yesterday's video when I did second mem and we did clear list? And there's also clear memory. Okay? But you could see I did this last in second period. So scroll up and you can see all the things that you've done since the last time you cleared the memory. So $60.20. Part B. Part B says John earned $93 in one day. So we want to know how far he drove. Do I have a new volunteer? Sebastian, how can I solve this question?
93 equals 0.08x plus 25.
Sounds good to me. Fantastic. And now we could be extra. We could use the graphing setup and graph this straight line and graph a horizontal line and look for the intersect. Or we could just do the basic algebra because I think it's a little bit faster to just get x by itself. So we're going to subtract 25 from both sides, giving us that 68 equals 0.08x. I didn't mean to keep writing that in green. I'm sorry. Well, it's too late. I've already done it. Now I'll divide that by 0.08 to get x all by itself. And I would like you to see that, yes, I have done that previously on my calculator as well. There is 68 divided by 0.08, giving me 850 miles. Which brings me to another important concept. AP will dock you if you don't use units. You will lose points if you don't use units. So please use units. Cool? Yes, sir? No. You would just lose a point for the unit. So let's say this question was worth like 5 points. You lost one of them. Okay. So the AP exam has some multiple choice and some what they consider extended response, which is not multiple choice. And they have that on a calculator portion and a no calculator portion for both, I believe. I could be wrong about that. I'm not sure. I look more into that. Yes, ma'am? Yes. It's a paper-based exam because you have to be able to do the extended response questions because they'll be looking at the work and grading the work. Any more questions on that? Yes?
Can I write miles instead of MI?
Of course you can. I was just too lazy to write miles. Alrighty, so these calculators are powerful things, but they are not perfect things. I'd like you to look at the title of this example. Seeing graph for failure. All right. We're going to graph this. It's telling me to use this window. So we might as well get practice adjusting the window. So y equals, let me clear out everything I have. Clear, 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 clear. And normally I would just hit zoom 6 at this point just to get me back to the standard window. But you see I did it after I cleared all the equations. That way I didn't have to watch them graph. Because watching them graph is painful when you know you typed it wrong. That sucks. I hate when that happens. Yeah, she says sad face. So let me go ahead and type this, and then we'll use that window, okay? Y equals 3 minus, not negative sign. You see this thing? This is a stacked fraction. Newer operating systems can do stacked fractions, but not all can. I know for a fact the 83 cannot do a stacked fraction. And older versions of the TI-84 cannot do stacked fractions unless their operating system has been updated. So if you can't do stacked fractions, you would do 1 divided by, and whatever's on the bottom of your fraction, you would make sure it was all wrapped in parentheses like I had to do in high school. However, I'm using a 84 plus, so it can do stacked fractions, and I want you to use them when you can because it's going to make less mistakes. Here is the shortcut for a stacked fraction. Alpha, which is the green button on my calculator, and then the y equals button. It brings up a shortcut menu. And as you can see, number 1 is n over d. So you just hit enter. And there's the stacked fraction. Alpha, y equals. So alpha is right underneath second, and then y equals is 2 buttons up from there. Did it work?
Yes.
She's saying yes, but her face says no. Did it work? Oh, okay. Then why'd her face tell me no? Anyway. Yeah, but you're a student. You can't trust students. Okay, 1 here. And then I'm going to press down to get into the denominator. And now I'm going to use square root. Square root is going to require me to press the second button to get the blue command. So second square root. X squared minus 1. X squared minus 1. Boom, baby. There it is. And then I'm going to hit graph. Ah, crap. I forgot to change the window. Now I got to wait for it. No, I don't. I just stopped this thing dead in its tracks. I stopped it from thinking. I don't know if you were paying attention, but it had a little yellow circle up here while it was working. I just stopped it dead in its tracks. I can't do anything with this graph right now. I literally told the calculator, stop doing all the calculations you were just doing, which means it can't do anything with this graph. The question is, how did I do it? in case you ever goof up and you hit graph or something like that, or you realize you typed it wrong, rather than waiting for it to finish its graphing process, because remember, timed test, try to shut the calculator off. If you try to shut it off using second on, it'll stop it from doing all calculations. And then I can go back and I can do y equals, or I can go to my window now, and I can adjust it appropriately. It wanted me to use this for my x values and this for my y values. Negative, which is the button down here on the keyboard, not on the side. So negative 4.7 was my x minimum. My x maximum was 4.7. It didn't give me an x scale. I'm just going to leave it at 1. My y minimum and y maximum are negative and positive 3.1. The negative is already there, 3.1. Y maximum, 3.1. Now I'm going to hit graph. So here's my question. Does this graph have x-intercepts? Doesn't look like it, does it? Okay. What about this? If there were going to be x-intercepts, what values of x do they appear to be around? Yeah. They look like they're about 1 and negative 1, don't they? So you know what I'm going to do? I'm going to adjust my window. But instead of guessing at the window, I'm going to do another fun command. I'm going to hit the zoom button. And I'd like you to look at number 2. It says zoom in. So I'm going to hit 2. The cursor is now blinking, and I can move it anywhere I want. And what I'm doing with that cursor is telling it zoom in, but use this blinking part as the center of the screen. I'm going to allow mine to stay centered at 0, 0. So I'm just going to hit enter. And it just zoomed in. Whoa! Those graphs clearly crossed through the x-axis. So what happened? Why did this screen that was zoomed out not show me x-intercepts? I'll tell you why. Notice that that is not a smooth curve. This calculator works like Minecraft. It can only color in pixels, and they're squares. But what this graphing calculator can't do is graph a vertical line. So what happened was, that was the last pixel it could fill in without trying to draw something vertical. Why can't it draw vertical lines? Because you're in function mode. And in function mode, you would be violating the vertical line test. That's why. So when you zoomed in, though, you basically made all of its x values much, much smaller so it could color in more pixels. Now, zoom in, it didn't really make the graph look very good. I didn't like what it did. So I'm going to go to Window, and my x values are fine. It's these y values that are a problem. I'm going to make them something like -2 to +2. And I should be able to see it cross through the x-axis now. Still didn't work. How about that, right? What about -1 to +1? Still not working. Maybe it's a problem with the x's as well. There we go. So we can see it clearly does cross through the x-axis. But I just wanted you to see all that. So yes, there are x-intercepts. Of course there are. If I asked you to solve this by hand, you could. You could add this fraction to the right side, like you set it equal to 0. You could multiply both sides by the square root bar. Then you could just solve a square root equation. Last example, happening right here. This one doesn't say graph or failure, but it says not seeing hidden behavior. Again, it's a machine. It's not perfect, and it operates on pixels. So it's gonna do a lot of weird things. So I'm gonna go to y equals, I'm gonna clear this, and I'm gonna type this new equation. So it says solve this graphically. I'm gonna type this as 2 equations because I really don't like to have to use the second trace 0 function. I'm gonna say that my y2 is just 0. So we have x, and the raise to the button is right here. Raise to the third. Now, if I type other stuff, I'm still going to be in the exponent position. So I have to hit the right arrow to drop it down from there. And now I can type the rest of the stuff. Minus 1.1x, there's the square button, plus, nope, excuse me, minus 65.4x, plus 229.5. And I'll let y2 be 0. It says first, try to use zoom standard, which is zoom 6. Zoom, the number 6. Whoa, steep line. Steep line. And there's the x-axis at y equals 0. How many times does it look like these two graphs touch each other? No, the red line, this is one graph. The red line and the blue line. How many times does it look like they touch? It does look like they touch twice. It does look that way. Let's go ahead and adjust this window. So press your window button. And it says leave the x's alone, but go to the y's. Negative 500 to positive 500. That is a span of 1,000. So unless you want 1,000 tick marks, which it can't even do, it'll just shade the y-axis. I'm going to say I like to have 10 tick marks, so I'm just going to make my stuff 100. There. Because 1,000 divided by 10 is 100. Basically, whatever the span is from min to max, I just divide by 10, and the number I get, that's what I make my scale. Now I hit graph again. As we can see, the blue line that was looking really steep, it really isn't. But now how many times did it look like they intersected? Still looked like twice, didn't it? Tell you what, let's go ahead and do second trace intersect. And let's find this one on the far left. Second trace 5. It says, is this blue one the first one? I go yes by hitting enter. Is this red one the second one? I say yes by hitting enter. It says, all right, go ahead and get close. All right, I'm going to go to the far left. I like going from left to right, so I'm going to the far left. That's close enough. Look at that. It's a perfect answer. X equals negative 9. What's that? Oh, okay. But you notice there's more directions. It says, then look closer what is happening around x equals 5. Okay, I'm going to hit zoom in, and I'm going to scroll over to 5. And I'm going to see what's going on around x equals 5. And I'm going to hit enter. It clearly drew blue graph underneath that x-axis. That means that red line is coming into contact with the blue graph there 2 times, not once. It's hidden behavior because it was a minute difference between the two answers. We need to zoom in remarkably far, but I'm not going to keep hitting zoom. I could hit enter again, it'll zoom in again, but I don't want to do that. What I want to do is I want the y values to get smaller. So go to window, I'm going to leave the x's alone, and those y minimums and y maximums are going to get really, really small. I'm going to go with like -1. Because when we saw it on standard, it didn't look like it went through the x-axis. So I'm going to go from -1 to +1, and I'm going to let my scale be 0.2. Again, I just did the distance between the two numbers and divided by 10. And I'm going to hit graph. And I'm expecting to see, oof, Still didn't quite do it, did it? I mean, it obviously went through, but what does that tell you? That tells me 1 and -1 was still too big. Window. I bet you I could go to 0.25 and negative 0.25 and 0.25. And you know what? I don't even care. We're just going to do this. We're just going to make life easy. Let's say the y scale is 1. We just want how many tick marks. Who cares? So now I'm at the quarters above and below. Come on now. Give me a good picture. At least they're not touching each other anymore. So we could do second trace intersect there. We could zoom in a little bit more. Let's just go ahead and do it. Second trace 5, yes, yes, guess. I'm pretty close to the one on the left. And it says the answer at the left one is x equals 5. And to find the one on the right, I'm going to do second trace intersect. Second trace 5, yes, yes. And I'm going to scroll a little bit to the right, and I'm going to click right there, and it goes, oh, that other answer? Yeah, it's 5.1. And there it is. And that's how we do it. Fun, right?